Hi everybody, welcome back to the channel. In this video we're going to talk about two really big rules about how to deal with derivatives. In fact, these might be the two biggest rules that we're going to look at. You can almost think about them as the same rule as one deals with multiplication and one deals with division. And oftentimes when we have rules or understand how things work with multiplication, things almost always work the same way or a very similar way with whatever we're doing with division. So these are similar, but they're important enough, they're big enough that I'm going to give them each their own name and treat them like two separate rules. Okay, so before we jump into what these rules say, I want you to look at, or I want you to remember what we talked about with derivatives with sums and differences. Okay, so remember something that when we talked about derivatives, we said that the derivative of a sum, so f of x plus g of x, okay, is that you can split this up or deal with each of the terms separately, where you can say, let me take the derivative of f of x plus the derivative of g of x, okay? So this was okay with a sum. This was actually also okay with a difference, so I could put plus or minus there. It works for both of these operations. And both of these were true back when we talked about limits as well, in that the limit of a sum is the sum of a limit, and the difference, the limit of a difference is a difference of limits, okay? But I do not think it's possible for me to emphasize this enough in this video, because this is one of the biggest mistakes I see in all of calculus, okay? So I'm going to see if I can write this big enough for this to kind of show you that this is important. This is not true for multiplication and division. Okay, not true. I could be yelling over here. This is not true. Not true. Okay, so what does that mean as to not be true for multiplication and division? Okay, let's take a look. So let's say we have a function f of x, and we are multiplying by a function g of x, and we want to know what happens to the derivative of the product, okay? What we're saying, this is not equal to f prime of x times g prime of x. This is not true. Okay, so let's look at an example. Why is this not true? We're not going to prove that. Well, I guess we're kind of proving that it's not true. Let's look at an example. Let's say that f of x is x. Okay, we'll just stay pretty basic. It doesn't take a hard example to show that this breaks apart or that this does not work. It actually doesn't work with some of the easiest functions you can come up with. So, say for example you have f of x equals x and g of x equals x squared. Okay, let's look at the left side of what would be up there. Let's take f times g first and then take the derivative. So f times g is x times x squared, which another way to write that is to write it as x to the third. All right, so what is the derivative of f times g? Well, the derivative of f times g is the derivative of x to the third. We know that from a power rule. We know that the derivative of that is 3x squared. Okay? So, we can look at this. Let me go ahead and pull up a new whiteboard page here. So we're saying that if f of x is equal to x, if g of x is equal to x squared, then the derivative of their product, the derivative of f times g, is equal to 3x squared. Okay? Now, let's look at the derivative of f and g separately. Okay? F prime is just 1. Okay, that's the derivative of x. G prime is 2x. Okay? So, f prime times g prime is equal to 1 times 2x, which is 2x, is 2x and 3x squared equal to each other? No, they're not. There's actually only one value of x that would make that true, and that's saying and that would be when x is 0. When we say are they equal, we don't just mean can we come up with a value of x where they're equal to each other. That would be solving an equation. What we're saying is, are they always true for every value of x? Clearly, no, they're not. Okay, so this does not work. So we need another rule, or we need a different rule to be able to deal with what happens when we have f of x times g of x. So these are going to be two rules, one with multiplication that we're going to call a product rule, one for division that we're going to call a quotient rule. And these are ones that you don't, not only do you want to put them on your derivative rules page on your notes, you want to put them in a big box, put a highlight on them, put a star on them, and say, I need to know these like the back of my hand, and I need to know how to use them, and I need to know when to use them. Okay, so let's start with the product rule. So the product rule says that when you have a function f times g, and you take the derivative of the product, okay, the way that you do that is that you take f prime times g plus f g prime. Okay, you'll notice that there are two different terms in here, and each of those terms contains a derivative, so we still do need to find f prime and we do need to find g prime, but we don't just multiply f prime and g prime together. There's also an f and a g in there as well. Okay, and don't worry, we'll see a lot of examples of this. But f prime times g plus f g prime. I will say this, multiplication and addition are both commutative, so it doesn't really matter what order you put things in. Some people like to remember this as f g prime plus f prime g, and basically kind of switch these two terms right there. That's perfectly fine because addition is commutative. So kind of find the way that you can remember this and memorize this and use this that you're comfortable with. For me, I prefer having f prime first with g, just because that's the way it's going to show up in the quotient rule as well. And that way you don't need to kind of remember two different formats or two different formulas. You can basically remember them exactly the same, or almost exactly the same, for both the product rule and the quotient rule. Okay, because here's what the quotient rule says. The quotient rule is saying that when you have division, which, by the way, is not commutative, unlike multiplication. So let's say you have a function f on the top and a function g on the bottom, and you're taking the derivative of that. Okay, so how do we take the derivative of that? Well, division is not commutative, and as you might guess, up top in the product rule, we use multiplication, and over on the right side, there was addition. So in the quotient rule, when there's division in the parentheses, on the right side, there's going to be not addition, there's going to be subtraction. Okay, so here's what the quotient rule says. It says f prime times g minus f times g prime. But then now that we have a fraction, we shouldn't be surprised that we should end up with a fraction as our answer. In fact, we saw this in a problem in one of the earlier videos when we had a rational function as our original function f. When we took the derivative using the limit definition of the derivative, we actually got another fraction as our answer. So we shouldn't be surprised to get another fraction as our answer. We actually end up getting g squared down on the bottom. Okay, so actually in the derivative, the bottom g that started on the bottom is actually going to be growing and getting bigger on the bottom as we go and we use this quotient rule. So, like I said, in the product rule, you can flip around the terms if you want to, because multiplication and addition are commutative. I don't really recommend that though, because then you're kind of lining up the f prime and the g with the f prime and g down here in the quotient rule, and the fg prime up here and the fg prime right there. And if you keep it in that order, then it looks like exactly the same order, and the only difference here then is that instead of addition in the middle, you have subtraction in the middle, and then there's an extra g squared down on the bottom. So again, These are two different rules. They're important enough to kind of each get their own name, but if you can remember kind of the format and remember that it's F prime G and then F G prime, then you can go ahead and kind of remember that same order for both of these rules.